coming back. I know it's been a long time since I did the first part to the build series in this engine. I just don't have the time to dedicate to YouTube that I would want to. I've got kids and a wife, one kid on the way, full-time job, a lot of stuff. This is my hobby, and just sharing with you is a lot of fun for me, so that's why I'm doing it. So if you're using my series of videos to build your small block Ford, hopefully you're finding them in like 2020, because hopefully they'll all be done by then. But regardless, we're back and we're going to jump into part 2 here. I've got some more parts for the engine coming together. What we have now is I've got the front end kit and all the pulleys. I got some rings and connecting rod gaskets, head bolts, head gaskets, and other little odds and ends to get the whole rotating assembly together, and maybe the heads, but probably just the rotating assembly together in this video. So we're going to start with taking a look at the rings. I'll talk about the rings I bought and why I bought them. We'll talk about setting ring gaps and checking them with feeler gauges, installing them onto the pistons and into the block, and then from there we'll go on to connecting rods and checking dimensions on that and sizing, or choosing rather, the correct size bearings for that. So let's jump into it, and hopefully we can get some stuff knocked out. Alright, so the first thing I want to talk about is rings. The rings I bought are just cast iron rings from Summit. So the direction this engine is going, it's going to be not a super duper power maker. I'm hoping to maybe get 400 out of it. Anyone that knows small block Fords know that with the stock block, the mid 5s is kind of all you can get, so I'm not going nuts. I might LS swap my car if I want to go nuts, but that'll probably upset some people, whatever. So anyways, cast iron rings. So let's open these up and take a look at them. So these cast iron rings from Summit are pretty good. I've used them in the past with good success. They are wrapped up here, and the interesting thing about it is the way they do it is they wrap them in the instructions. So as you can see here, the instructions are right there. These are the compression rings. Compression rings. You know, because it says right here, compression rings. And then after that, we've got more compression rings. These are thicker. This is the second groove. The first set of compression rings go in the first. Second set obviously go in the second. Or this set happens to go in the second set. And then we've got our oil rings. And they come up with a spacer and then a spiral steel piece that kind of holds onto the oil. And that's what these look like. These all look familiar, I'm sure. So number one thing we need to do is we need to set the gap on the compression rings. And we're going to do that by rolling this engine onto its side, so we have the specific cylinder that we're working with. We have a dedicated size to that. So when I had this engine board, I had it matched to the pistons I had, which I highly recommend. Don't just take your stuff to the machine shop and have it all punched out 30 over, because everybody's 30 over is not the same. So you need to have it matched to your pistons. So all my pistons were probably like plus or minus a half thou or something like that, within tolerance of each other. But if you have a good machine shop, they'll have no problem punching that hole to match that piston. So since I did that and all my pistons are different sizes, I'm going to locate my number one piston, my number one hole, grab a set of rings and size it for that hole. So you're going to end up having to do this 8 times. 8 different times. You don't get to just do it once, say, oh, I got to pull X amount off this thing and then slam them all in there. You've got to do it 8 separate times to make sure you get this correct. So let's take a look at what that looks like. For the ring gap, what we're looking for is, the math on it is about 4 thousandths per inch of bore. These are bored at 4.030, so 30 thousandths over the 4-inch standard bore. So the math on that is 16 thousandths. But for an NA engine, really anywhere between 10 and 20 thousandths, you're going to be in the range. A boosted engine, you probably can open it up. I don't know, I've seen guys, depending on the ring material, run gaps as large as 25 or 30 thousandths, depending on boost levels and heat that they know that they're going to see in the combustion chamber and all that stuff. But for us, we are going to go in between 18 and 20 is what we're shooting for both the compression rings. Like I said, that's in the stock neighborhood. From 10 to 20 will be fine. Now, the reason you want a ring gap, and the reason ring gaps are so important, is because this gap right here, you can see, if this material were to get larger, since it's in a round shape, it's going to grow together, and it's going to shrink that gap up. So what happens is if that gap were to shrink, it will constrict on the piston. And if it does that without anywhere to go, it could pop the top of the piston off, basically. And it could do a lot of real bad stuff. So we want to make sure that these ring gaps are set appropriately, not only for the engine that we're building, but the kind of use that we're going to do with it. So again, higher revving, anything that has higher heat, you need to open those things up a little bit more. So let's take a look at this one and see what it's measuring out at. So what we want to do is, I know these bores are true. If you are re-ringing a bore that is not true, you want to find the tightest spot on your bore, because bores get tapered over time, because all the monkey motion gets loose, and this piston will push on one side of the bore more than the other, and it will taper the bore. You need to find the least or the smallest measurement and do all your work down there. If it's tapered at the bottom, you need to take all your measurements from the bottom. If it's tapered at the top, you need to take all your measurements at the top. This bore is true, and I know that. So what I'm going to do is I'm going to use this number 1 piston right on top of the ring here, and I'm going to seat the ring down into the piston an equal amount. I'm just going to hold my fingers right here on the piston, the shelf of the piston, where the pin goes in, and I'm going to push it down until it's even on both sides. And then I'm going to retract the piston very carefully and take my measurement. It's important to do this dry. You want this dry because a fluid film can throw off your readings. So I'm going to start at 20 and see where I'm at. I'm just going to come down here into the bore and put my 20 feeler gauge in there. It is too tight, so I know right off the bat I'm in my window, which is good because I didn't want to buy more rings. Okay, let's go 19. We're going to see where I'm at 19. 19 is right there. Okay, so my top compression ring is 19 thousandths, and that's in the window of 10 to 20. It's on the top side of that, which I want, because if down the road I do decide to put a turbo on this motor, or I'm just running the snot out of it, I like the peace of mind knowing that those rings have somewhere to grow, and they're not going to pop the piston tops off my forged pistons. So, all right, let's pull this out and take a look at the second ring. The second ring has something that's just a tad bit different. Okay, second compression ring is marked top. Let's see if you guys can see that. There it is. So this ring obviously needs to go in this way. The measurement we get on this should roughly be the same. I don't want it any smaller than the first measurement, so if it is, I may take some material off. So we'll set it in there, and then I'm going to use the piston, number 1 piston again, to set it down into the bore. And there we go. Pull the piston back out. And we'll start with our feeler gauge here at 19, just like we were. Okay, 19. That's a little tight at 19. Let's try 18. And 18. Okay, so it's 18. I'm in the window there again. Do I want to open that up? I could, but in all actuality, I'm fine with that. One of the concerns you'll often hear is that, if you open that thing up too wide, referring to the ring gap, you're going to get blow-by and lose power. That's simply not the case. As fast as the event is happening in this chamber, will you, volumetrically, yes, you'll probably lose a little bit. Anything that you will see in your chair as a driver, 100% no. Unless they're broken and missing a chunk and you could stick your finger in there, that hole is going to make very comparable compression to the rest of them. So while this is a precision operation, just understand that if you overshoot or undershoot a little bit, it doesn't need to be perfect. It's a little bit of a science, a little bit of an art. You're going to be okay. So let's pull this one out and take a look at the oil rings. Okay, now oil rings. Oil rings typically do not need to be sized. The reason being is that all the compression action is happening above these, and these are basically used to scrape the cylinder walls or ride the cylinder walls and move oil around as appropriate. So let's put this in here just for gee whiz and kind of get a measurement and see where it's at. Let me grab my piston here. Boy, those go in there real easy. Okay, there we go. Let's take a look at where this is at. And I can tell by looking at it, it's huge, or at least much larger than the compression rings, which is fine. There's 22, 23. Let's see if we're at 24 yet. Okay, so they're over 24 thousandths. Who cares? So the way that these go in the third land, or the large land on the piston in here, is you're going to go flat ring, wavy ring, flat ring. And that is the setup for the oil. So compression, compression, oil. Whoop, can you see that? Compression, compression, oil. So building cars is like anything else. You ask 5 guys how to do it, you're going to get 5 different explanations. This is how I do it. This is how I'm going to do these piston rings. It's not right or wrong or indifferent. It's just the way that I've been successful with. So the first thing we're going to do is I like to start from the bottom and then go up. And on the oil rings, there's no special tools. We're going to run them in by hand. And in the compression rings, we're going to use the ring pliers. So if you remember, the stack up for the oil is a flat, a wavy, and a flat. But when we install it, we're going to put this wavy one on first. And I'll show you why here in just a moment. Just walk it around the circumference of the piston there, and it'll pop right in. Now, the reason you want to put that in first is because if you look at the oil ring real closely, there's some, hang on, let's see if we can't. There are some steps right in there. And what that area is for is the other side of the flat ring kind of rests against it. And when it does that, it makes installation a little bit difficult. So if you put these wavy rings in first, it's a lot easier to get the outside ones in. So we got that one in, and then we're just going to walk the small one down around the piston in the same way. And it just pops in. Maybe, sometimes. There we go. It's in there. Okay, and now the next one. There you go. Now your oil rings are installed. Okay, next up is going to be the larger of the 2 compression rings, which is the small one. Remember, it has a top-up indication on it right there. I swear it's in there. Trust me, that says top. So for that one, we're going to use the pliers. And the pliers are super easy. They're just little wedges, like so. And then we're going to install this ring. So we'll open it up just past the diameter of the piston and work it down to the second ring. There it is. And now the first one, we'll get it loaded back up into the pliers. Remember, this one, it doesn't matter, it's kind of omnidirectional, up or down, whatever. And we'll load these onto the top. Now earlier I said that these were cast iron rings, and they are, but this top ring is moly. Just FYI. There it is. That's a loaded up piston right there. So you've got 1 and 2 compression rings, and then your flat, your wavy, and your flat on the oil, and that's ready to go. So unfortunately I did lose some video of how I actually file down the gap. It's nothing super crazy. All I'm doing is basically putting a mill file in a vise, and here's what that looks like. I got a clip of it here. So I just put the mill file in the vise, and then what I do is stand the ring on end, and then holding it in my hands, just run it up and down, and then deburr it. So just run the file around the edges as well, wherever I filed, and then reinsert it back into the cylinder and take another measurement. Do that 2 or 3 times. Just make minimal passes and take off as small as you can until you get it right. So after that, we got everything loaded up and started loading the pistons. Okay, we've got the piston ready to go here, and we want to make sure that it's oriented correctly. Most pistons have a arrow on the top facing the front of the engine, so we're just going to line that up and drop it down the bore. Make sure the crank is lined up at the top of the stroke. That way the rods are going to be lined up right where they need to go. There it is. Now we'll just take a deadbolt hammer and slowly drive it home. Periodically take breaks and come down here and check. Make sure everything's lined up on the crank as it should be. It looks good. So I keep sanding it here. Okay, we're getting up to the rings here. I can feel them there. Well, there's one ring that doesn't want to go. I can feel that. It's stopping right there. So I felt a little bit of resistance, so what I'm going to do is I'm going to tighten up the ring compressor tool, see if I can get any more out of it. Yeah, I got one little turn out of it there, which is telling me it wasn't all the way tight. Actually, what we need to check is the crank, make sure I'm not smashing against the crank. So at this point, I was obviously having an issue, and you can see me tapping the compressor in a circular fashion. Sometimes the lip of the compressor will stand on top of one of the rings, and if you tap it down, you can kind of work the ring back in it. You need to be really careful when you do that, and that's one of the downsides to this style ring compressor, is it does get a little bit finicky, but with a little bit more attention and some love, we got it to go. There it goes. Had to give it just a little more love. Always makes me nervous sending these things home like that. There we go. Alright, first one's in. I always take my time with that stuff. It definitely makes me nervous sending it home like that, but this one worked out good. Alright, we're going to continue until the bearing is set in the crank. And that's it. Alright guys, we got it in there, and I got the rod cap installed, and the bearings are on there. One thing I forgot to mention is that you need to have assembly lube in the bearing surfaces and on the crank journal prior to assembly. I use this Royal Purple stuff. It's really good. It's like honey. It sticks to everything, and it doesn't run off. So Max Tough by Royal Purple. It's all synthetic stuff. It's good stuff. So anyways, assembly lube, make sure you use it. So the rest is just, it's basically a repeat of that. you'll want to grab your loaded piston, make sure the cylinder is clean, and then pre-lubricate it with some motor oil. Just reach down in the bore and wipe it down, get it all nice and lubricated, and then load your piston into your ring compressor, and then load the piston into the block. Make sure you've got the crank, so that journal of the crank is right up and down in the middle of the bore, and then just drop it in. And the first set of connecting rods per side go really easy. When you start putting in the adjoining one, or the one that shares that journal, it gets a little bit more I guess kind of intricate. You just want to pay a little more attention, make sure you're not smashing anything, but it's really pretty easy too. I mean, everything kind of is designed to go one way only, so it's really kind of hard to mess up. So you can see here I turn the crank over, and then I'm making sure that everything is pre-lubricated with assembly lube, and I also have lube on the bottom side of the cap bearing as well. So we're just going to speed it up here so you don't have to stare at me do the same thing 6 more times. But yeah, that's all there is to it. Alright guys, we got it done. The bottom end is assembled. We got all the pistons and rods in. All the connecting rod caps are torqued. And everything went really well. We didn't damage anything. I put a torque wrench on the balancer bolt here to turn it over. It's less than 20 foot-pounds. I couldn't even get the wrench to click. So it's real low friction. All the bearing tolerances were good. So I'm super happy with how this motor is coming together. And I hope I can make some good, reliable power with it. So anyhow, if you like this stuff, please continue watching. Thumbs up, subscribe if you're into this kind of thing. Next video, we're going to put the cam in and the timing set on the front. We might do the timing cover and the cylinder heads, and then maybe measure for pushrod length. So we're still waiting on some parts to come in, but yeah, as soon as that comes in, hopefully we'll get this. I say we, it's me. I'll get this other video put together, and hopefully I can have it out to you guys within a month or so. I'd really like to get this car going this winter, so that's a motivator for me. So anyways, thanks again for watching, and watch for the next one coming out soon, hopefully. Thanks.